Okay, this will be part 3 of section 5.6. And what we're asked to do here, and keep in mind you want to copy this inequality down. I'll do it here too. Negative 5 is less than 4x minus 1 is less than 11. We want a strategy to do this. Now the key is, whatever we do to one part of the inequality, you want to do this to the other part as well here. I'm going to change colors. Let's use black here maybe. So we want to get the 4x isolated. So we're going to use this technique. We're going to add 1 there, but then we must add 1 there, and we must add 1 there. So now this becomes a negative 4 is less than or equal to 4x. This canceled out and became a 0, and this is less than 12. So again, we want to isolate the x, so we're going to divide this by 4, this by 4, and this by 4. So here this becomes a negative 1 is less than or equal to x is less than 3. And then I think we can graph that. Negative 1, 3, bracket here, parenthesis there, and filling it in. And interval notation will be bracket, right from the graph, negative 1, comma, 3. Okay, now I'm going to skip the book presentation because that just takes up time. Okay, I've written this one out as well. Take a moment, pause if needed to copy it down. Now again, we want to isolate the x term here, so I'll change colors again here. And we want to get rid of this negative 3, so we're going to add 3 here. We must do it to each part. So now this is 8 is less than or equal to negative 2x, these disappeared, is less than or equal to 16. Now here this is a little tricky, so note what's going on. To get rid of the negative 2, I have to divide by a negative 2. Divide this by a negative 2. And what did we say just a little while ago? That when we divide inequalities by a negative, we have to reverse all the inequality signs. So let me see. I want to be sure to reverse that. This will be greater than now or equal to. This one is going to be greater than or equal to. So I now get an x in the middle. This cancels out. This becomes a negative 8 here. And this becomes a negative 4. Now, again, to make this seem reasonable, we want to put the lesser value on this side. So I'm going to rewrite the whole thing. Negative 8 this way. And again, the point is toward the 8, like so. The x is still in the middle. Now the point going this way is toward the x. And then now that seems reasonable. So when we graph that, this is negative 8. This is negative 4. We're going to use brackets and shade in. And then interval notation, bracket, negative 8, comma, negative 4. And there's our answer. And again, I'll pass up on looking at what the text is offering here, because that's just going to take too much time. Take a moment now to write this down. And we want to, again, isolate the x. And I'm going to change colors here. So a couple of things. We have a fraction. So the same rule, we're going to multiply, this is one term, this is one term, this is one term. Each term by 4. Now, since this is all one term and I'm multiplying it by 4, here the 4's will cancel out and multiply this by 4. So it's much easier. So 4 times 0 is 0. This is less than 3x minus 5 is less than 3 times 4 is 12. So just taking a moment to see what's going on. We've just copied it. We want to get rid of the fraction, multiply each term by the fraction. Here it cancels out, and I've rewritten it and multiplied through. Now, I want to get rid of this negative 5. So I'm going to add 5 here, add 5 here, add 5 here. So this is now 5 is less than 3x. Here the 5's cancel out. This is 0. And this is less than 17. And I think you know what's going to happen. To get the x by itself, I'm going to divide everything by 3. And since it's a positive 3, I don't have to worry about changing any inequality signs. So on a number line, to graph that, that will be 5/3. This is going to be 17/3. We're going to fill in this part. And the signs I'm going to use on the number line are parentheses. And interval notation would be parentheses, 5/3, comma, 17/3, parenthesis. Okay, again, we're going a little fast, but I don't want this to be too long. You can pause it as needed. You want to understand what goes on each step, and you can always replay. And for this one, let's look at the book here. So again, they're multiplying each term by 4. Now we're getting rid of the negative 5. They're using it horizontally. I like that vertical method. We get this. Now we're going to divide each term by 3. And there's our inequality. And there's our graph. Now it's nice the way I do the graph because I just write the numbers underneath. Here you have to sort of put it approximately where it would be. And there it is in interval notation. Okay, let's take a look at this one. A math student has grades of 85, 98, 93, and 90 on 4 examinations. We did one like this earlier. If he must have a mean score of 90 or better, so he wants to have greater or equal 90 or better to receive an A for the course, what score can he receive on the final exam and earn an A? Well, we'll use this because it's one we've done already. So there's the formula. There are your 4 scores. X is your 5th unknown score divided by 5. Now it has to be greater or equal than 90. So we're going to multiply both sides by 5. Well, they added those up first and then that. Now they're going to multiply both sides by 5. So on this side, the 5's cancel out. We're going to subtract this from both sides. And he must earn on his final exam greater or equal to 84. So again, we did one very much like this in an earlier lesson, except it wasn't in the inequality form. Pause it, look at it, put it in your notes if you get one like this. If it were a quiz item, I'd give you this exact same question, so you already know the answer. Okay, Ellen is going to buy 30 stamps. Some will be 28 cents, and some will be 44 cents. If she has this much money, what is the maximum number of 44-cent stamps that she can buy? Okay, now if you remember, we had used a similar type of question earlier where we know we have a box, and draw this on your notes, and this is 30. Now how can I divide that 30 into two parts? Well, part of it we said was x, and the other part was 30 minus x. So, let's say that x will be the number of 28-cent stamps, and 30 minus x is the number of 44-cent stamps. And let's see, she has this much money. So, we go 28, and this is cents, times x, plus 44 cents, so 44 cents, times 30 minus x equals, and let's see, what is she, maximum number has to be less than or equal, I believe is what we're going to put there, 968. Again, as I say, we did one very similar to this. The key is how to divide that 30 into two parts here. So, first thing we do, get rid of our decimals, multiply through, we'll know the number of x stamps, and then when we subtract it from 30, when we solve it for x, we'll know those that can be 44 cents. All right, well, let's take a look at this. Okay, now they're setting this up a little bit different than I did, and I think this is a better idea than the way I did it. Because instead of letting the 44-cent stamp equal the 30 minus x, if we let the 44-cent stamp equal the x, that's going to be our answer. And then we don't have to subtract it from the 30. So let's just follow. And then there's the other. And again, you could designate either one, and the beauty of algebra is you solve it that way. So there's our basic equation, except I had the 28 here as x, and the 44 here. And I think it's a good idea that you put what you're looking for, the 44, as the x. And let's go on. And they're solving it. Again, pause is needed. They're not getting rid of the decimals. I would have. And then they get that x is less than or equal to 8. And that's your answer. Okay. All right. Since this is going to be a little bit different, we're going to have a 4-parter here. We're going to keep this at about 14 minutes, and we'll pick up here on the next one.